Hey everyone, welcome to a new semester of Algebra 2, and I'm here to start our new unit today, which is going to first cover a topic that's going to be very pivotal to a lot of the things that we're going to talk about this semester, and that is transformations. Transformations is something that's going to apply to the unit that we're going to cover this next month on square roots and cube roots, but also what we're going to talk about today has applications to a lot of our different units in the future on exponents and logarithms and a lot of other functions that we'll see can be transformed. So this might have been something that you saw back in Algebra 1 or geometry, but if you haven't seen transformations yet, that's okay. We're going to start from the ground up, and the way I like to start by talking about transformations is using a metaphor, and today we're just going to be looking at transformations in general, transformations that can apply to a general function. So the most general way that we would write a function is f of x. Everybody by this point should have seen this notation. This just refers to a function. All functions have graphs. And we're going to describe this general way to refer to a function, f of x, as a parent function, meaning just like we all have parents and we all look like our parents to some extent or another, we're not exactly the same, right? We have something that's different about us. And so starting from a parent, we know that a parent can have a lot of different children, okay? You might have a lot of brothers or sisters. They look somewhat like you, but a little bit different, and they all look like, you all look like your parent, but again, a little bit different. So what we're going to see are what's called transformations. And these transformations somehow take the parent and change it just a little bit, okay? So there's going to be a total of, I believe, 10 types of transformations we're going to talk about today and in this semester in general, actually. So what types of transformations can we find? Well, one transformation that we'll see is if we take this parent and add a number off to the side. Now, what is that going to mean? What I recommend is that you open up desmos.com/graphing, and as we're going through these things, in the first line, I would want you to type in f of x equals the square root of x, since we're going to end up looking at this type of parent function in the future. Go ahead and type that into the first line, and a graph will pop up. Okay, it'll be like a little jump towards the right. And when you, in the second line, type f of x plus 1, what that's going to do is show you a different graph. It's going to be very similar, okay, as far as the shape, but it's actually going to be shifted up by 1. It's going to take the original parent, that square root graph, okay, it's going to move its location up by 1. It's going to be the same shape. It's going to jump off towards the right side of the page. But that's one type of transformation we can see. Another one that we'll see is subtracting off to the side. This will be when we shift down by 1. Okay. It'll take the graph that you start with and move it down by 1. If we add on the inside of parentheses next to x, that's going to move or shift our graph left by 1 unit, versus if we subtract next to x, that's actually going to shift our graph towards the right side of the page by 1 unit. Okay. So left and right, up and down, our graph can move these directions if we change the original one that we're given and add or subtract either off to the side. It's going to shift things up, or inside will shift things left and right. If we have a negative in front, that's going to mean what's called a reflection over or across, in this case, the x-axis. So what's that going to do? Well, it's going to take the original graph that you're given and flip it upside down over the x-axis. So instead of jumping up towards the right like the graph will originally do, it's going to flip that when you have a negative multiplied to the front of your function. Whereas if you have a negative inside those parentheses here, it'll still be a reflection. So whenever you see the word reflection, think negative, or if you see a negative, think reflection. But in this case, it's going to be a reflection across the y-axis. So instead of flipping upside down, in this case the graph's going to flip from right to left over the y-axis. You'll see that the graph starts going up towards the right. Well, when you're reflected over the y-axis, it's going to flip over towards the left side of your page. Okay. A couple more transformations that we can see here are when we multiply by some numbers. If we multiply in front of our function, that's going to end up being a vertical stretch or shrink. In this case, it's going to be a stretch by a factor of 2. Or in this case down here, we're multiplying by a number less than 1. This is what's going to be called a vertical shrink by, in this case, a factor of 1/2. Now what does this do? If you, again, go to the graph, type this in the second line, what you'll see is that the graph can stretch taller or shorter depending on the number that you multiply by in front of your original parent function. So in this case, here we would stretch it, it's a number bigger than 1, versus here we would shrink it because it's a number less than 1. And just like we can have vertical stretches and shrinks, we can also have horizontal stretches and shrinks. This one's actually the tricky one because whenever you see the word horizontal, you need to think the word flip. So whatever number you have inside parentheses, you're going to want to flip that upside down. So in this case, we're going to have a horizontal shrink because the number that we're going to flip is that 2. 2 will flip to 1 over 2. And 1 over 2 is less than 1. That'll be a shrink. Versus, in this case, we'll have a horizontal stretch because we'll end up flipping this number 1 over 2 to be 2 over 1. Or in other words, 2 over 1 is just 2. Okay? So if you type this into the graph, it's going to stretch the graph horizontally away from the y-axis. For this one, it'll actually shrink the graph closer to the y-axis. So these are the 10 types of transformations you can have. And the way that these have changed your parent are by changing different letters of this formula. A, B, H, or K. A, B, H, and K. If you change one of these numbers, that's going to mean one of these transformations has happened. So for example, when we added off to the side and subtracted off to the side, that changed K, right? That's a new child transformation. Okay, we've done something different to the parent. We've added by a number off to the side. That changes things up or down. If we change H, right, on the inside of parentheses, always wrapped in its own parentheses, we're moving left or right. If we change B, okay, we're multiplying inside brackets, but again, that's separate from anything that moved left or right. That's going to be a horizontal either stretch or shrink, or it might be a reflection. Okay, that happens inside of parentheses. And lastly, if you change A, if you multiply in front, either by a negative or by a number, you're going to have a up and down either reflection, right, a flip of the graph, or maybe a vertical stretch or a shrink. So what might be helpful here is to notice, number one, these are all in alphabetical order. If you change A, B, H, and K, if you remember that order. Another thing that might be helpful is if you change anything outside of parentheses, it means something vertical has happened. Either you've moved up or down, if you add off to the side or subtract off to the side, or if you multiply in front, you vertically stretched, shrunk, or flipped your graph. So that's vertical movement. Versus anything inside these brackets or parentheses will be horizontal. Either movement or stretching or shrinking or reflecting. So adding or subtracting inside moves left or right, the graph. It doesn't change shape, but it changes the starting point of the graph. Versus if you multiply inside, it's going to stretch or shrink horizontally or flip horizontally, depending on if you have a negative or not. So That's the general notation for what we'll be looking at as we're starting to take a look at some other transformations here. I do have two more examples I want to get to. And one is going to be where we are creating something that looks like this in function notation. We're going to create a transformed function. And in another example, we're going to describe a transformation. So what you'll notice in both of these cases is that we can have transformations happen more than one at a time, right? We can combine transformations. A graph can move up and down, right? But it can also move left and right at the same time. You can have multiple transformations happening in the same child function or same transformation, okay? Or transformed function, I should say. So, for example, notice here we have a lot of transformations happening. We still have f and we still have x, so it's related to our parent, but there are a lot of other numbers and then a negative here as well. So how would we describe in words what has happened here? Okay, what we'll see is that this negative means we have a reflection across the x-axis. Now, why is this the case? Well, just like we saw before, okay, whenever we multiply by a negative in front of our parent function, like we're doing here, we're multiplying by a negative, we have a reflection across the x-axis. This is one transformation here. Our graph will flip upside down. Not only that, but it's also going to vertically shrink by a factor of 5/6. Now, why is it shrinking? Because in this case, the fraction is less than 1. So the graph of the parent should shrink vertically. Then we see it here, okay? We have multiplying happening inside of our parentheses as well as outside. This is going to indicate horizontal stretch or shrink. Don't forget, when you see the word horizontal, you want to think the word flip. So this is going to turn into a 4/3. And while that's a fraction, it's also bigger than 1. 4 divided by 3, if you check a calculator, is like 1.33333 forever. Okay? That's bigger than 1. So this is a stretch by a factor of 4/3. Flip that fraction if it's horizontal, if you're multiplying inside of brackets or parentheses. Here, we're moving either left or right. Notice that gets wrapped in its own separate parentheses. Anytime you move left or right, that's always in the parentheses next to x on its own. So here that means we are moving right by 2 units because we're subtracting. Okay, just like before, when you subtract next to x, you're shifting to the right, or you're moving, or you're transforming to the right. And then lastly, our final transformation is happening for this transformed function, this function notation. Last thing here, we're moving 12 units up. We're up by 12 units, shifting that direction. Our graph will indeed have a location that has a new starting point. It'll be to the right by 2 and up by 12. Okay, it'll also be flipped upside down. It'll be shrunk vertically. It'll be stretched horizontally. So a lot of things happened here. We have 5 different transformations, in fact. But sometimes that happens, right? Sometimes we have a lot of things going on for one new type of transformed function. So this is how you would describe, using words, what has transformed. Now, for our last example today, instead of starting with numbers and negatives and giving words, I want to look at what happens if we're given words and have to write a transformed function or function notation for these descriptions of how we could transform a parent. So let's say that we have a parent function, right? And that parent function again is f of x, just general function. Okay. What happens if I reflect that across the y-axis and vertically shrink it and horizontally shrink it and so on and so forth? What happens? Is f and x the only thing that show up anymore? Obviously not. There's other things that are happening now. For example, that vertical shrink means we change a, right? We're going to have a 1 over 9 in front of f. Okay, f, x, these still show up just like they did in our parent. They'll show up down here as well in our child or our transformed function, but obviously we have to account for these transformations as well. So that's one thing we would check off. A has changed. We have a vertical shrink. Okay. We also have a reflection across the y-axis. So what does a reflection across the y-axis look like? Negative should be on the inside. And I'll move this a little bit further down. Negative should be on the inside of our function. So in this case, I'm going to use brackets here and put a negative. Negative should go on the inside. Check. We have a horizontal shrink. Now, whenever you see the word horizontal, remember, think the word flip. See the word horizontal, think the word flip. So we're going to flip this fraction upside down. That's going to become a 7 over 2. Once again, we're changing b here. Okay? We're multiplying inside by a negative as well as a fraction. We're flipping that fraction upside down. Negative 7 over 2. Check. We're shifting to the right by 8 units. So that changes h. Again, we're moving horizontally to the right in this case. We're going to put that in parentheses by itself. Again, whenever you move left to right, that gets its own separate parentheses. And so we close that parentheses, and now we close the bracket. And finally, after we check that off, we move down by 5 units. Whenever we move down by 5, don't forget we are subtracting off to the side. We're changing, in this case, k, right? Minus 5 off to the side. Now, a quick note here is that there's 2 ways to write this answer. This is one, but you could have also written the answer like this. Negative 5 plus 1 over 9, and then everything on the inside of that parentheses would stay the same. Okay. The main difference here is that negative 5 can show up on the right side of your function notation, right, your transformed function, or it can show up on the left. As long as you're not multiplying by it, right, you're adding by a negative or you're subtracting, those mean the same thing. Either way, your graph will indeed move down by 5. So this is the normal way you would write it. That's the way I'm going to be expecting you to be able to know for a test. So don't worry about this one too much. I just wanted you to be aware of it. And that is all the transformations you can expect to see from this, not only this unit, but the rest of the semester. So we're going to apply these transformations to specific parent functions. Right? We're going to apply them to square roots and cube roots, but it's always going to be the same pattern. You're still going to have a, b, h, and k. You can change all those numbers or all those different types of placeholders for different numbers or negatives, and you can do these more than at once. You can see these graphically. We'll get into that a bit more in our next lesson, specifically on square roots and cube roots and transforming those, and I'll look to see you back then. So I'm excited to have you back.